Hey everyone, welcome to the Dynamic Programming Lecture Series. In this tutorial, I am going to cover Introduction to Dynamic Programming. What is dynamic programming in programming world? Components of dynamic programming. Characteristics of dynamic programming, which includes optimal substructure property and overlapping subproblems. Dynamic programming methods, top-down with memoization and bottom-up with tabulation. Before moving ahead, make sure you have subscribed to this channel and click the bell icon so that you won't miss any update from JAVAAID. Introduction to dynamic programming. Let's do some quick exercise first. To get the feel of dynamic programming, writes down 1 plus 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 1 equals on a sheet of paper. What's that equal to? Counting 8, writes down another 1 plus on the left. What about that? Quickly 9. How'd you know it was 9 so fast? You just added one more. So, you didn't need to recount because you remembered there were 8. Dynamic programming is just a fancy way to say remembering stuff to save time later. This conversation has the essence of dynamic programming. The idea is very simple. If you have solved a problem with the given input, then save the result for future reference, to avoid solving the same problem again and again. Shortly, remember your past. Let's see, what is dynamic programming in programming world? Dynamic programming is a powerful technique that allows one to solve different types of problems, in polynomial time for which a naive approach would take exponential time. Let's take the very known example, Fibonacci numbers, to understand a little bit more. In which each number is the sum of the two preceding numbers. The first few Fibonacci numbers are 0, 1, 1, 2, 3, 5, and 8, and so on. If we are asked to calculate the nth Fibonacci number, we can calculate that with the following recurrence formula. A naive recursive implementation of Fibonacci function has time complexity of O2 raised to the power n time, where dp solution can achieve the same with only On time. Components of dynamic programming. The major components of dynamic programming are recursion, which used to solve the subproblems recursively. Memoization, which is used to store already computed value in the table for caching purpose. Based on that, we can say dynamic programming equals to recursion plus memoization. Characteristics of dynamic programming. Let's look at the characteristics of a problem that help us to identify whether DP can be applied to solve the problem or not. Optimal substructure property. A given problem has optimal substructure property, if an optimal solution of the given problem can be obtained by using optimal solutions of its subproblems. As we know, to calculate the nth Fibonacci number we use below formula, which clearly shows that a problem of size n has been reduced to subproblems of size n-1 and n-2. It means Fibonacci numbers have optimal substructure property. Overlapping subproblems. Subproblems are a subset of the original problem. Any problem has overlapping subproblems, if finding its solution requires solving the same subproblem again and again. Let's take the same example of the Fibonacci numbers. To find the fib 4, we need to break it down into the following subproblems. Dynamic programming methods. Dynamic programming approaches extend the divide and conquer approach with two techniques. Top-down memoization, and bottom-up tabulation, both have a purpose of storing or caching, and reusing sub-problem solutions, that may drastically improve your program performance. For example, a naive recursive implementation of Fibonacci function has time complexity of O2 raised to the power n time, where dp solution can achieve the same with only On time. Here is the recursive implementation. Top-down memoization. It's a similar approach to recursion, as it looks for value in the table first, which acts as a cache, before computing solutions. If the problem solution is found, then the result will be taken from the cache, otherwise the problem will be solved and the results are likely to be stored in the table for future use. Here the table is filled on demand of the problems, that may be an array, map or 2D matrix, which totally depends on the number of the state, which you have to store to solve the problem. So far, we have seen the recursive implementation of Fibonacci number, now apply memoization to it. If you compare both the program, you can see only cache lookup has been added to the previous solution and rest are almost same. Note, if you use the top-down approach you are not going to fill all the entries. Bottom-up tabulation. Tabulation is the opposite of the top-down approach and avoids recursion. In this approach, we solve the problem in bottom-up manner, by solving all the related sub-problems first. This is typically done by filling up all entries in an n-dimensional table. Based on the results in the table, the solution to the original problem is computed. Let's apply tabulation to our example of Fibonacci numbers. Since we know that every Fibonacci number is the sum of the two preceding numbers, we can use this fact to populate our table. Here is the code for our bottom-up dynamic programming approach. I hope you have enjoyed this lecture. If you find it useful, let me know in the comments below and do not forget to share with your friends.